SDC is very, very important, I think, in a lot of ways. It was run by students. It was a student project, and that's the important part of it. It's run by students, and it's designed, created, everything. And so that makes a unique challenge in that you have to hand it off to this next group of students. But it also is extremely rewarding. And that's the second part. And I got to see this firsthand. I mean, imagine to be on this project where this was 12 years ago when I started. And I knew that this thing was going to go to Pluto, and nobody had ever been. And it seemed like a far way off, but it was just so exciting to be a part of that.
The team kind of became a family as we were working on it, and so we were a close group knit. Knit group. We hung out outside of work a lot, and we all went down to the launch together, and it kept getting delayed, so our anticipation was building, and when it finally went off, I think several of us had tears in our eyes just because it had been so much hard work. And
when I originally started working here, it wasn't for New Horizons, it was doing something completely different. And then when I started working on SDC, I got to do flight software stuff, and that's what I do now, and that's what I've been doing, and that's what I want to do, and so it gave me that opportunity to find out that's what I want to do.
So while I worked on SDC, I was a grad student, and I was the head of the Detector Subsystem. The Detector Subsystem, it's actually where we are hitting or detecting the dust particles.
They're about the size of a dollar bill. They're real lightweight, but they respond to a dust particle impact. So whenever they impact this, we have these wires, and we just get a signal. And so the signal, the strength of the signal is relative to how big the particle is. So and then we know where the spacecraft is, so we know where the particle was when it impacted. And so we get the mass and the velocity from this little signal that it creates on these wires. Here is actually it. So you can see that these guys would go behind here on the actual panel, and this was the cover to keep dust and debris out while they tested it. But there's 6 on this side, 6 on that side, and there's actually 2 on the back. And those are reference detectors. So Pluto is very, very interesting in a lot of ways. But for us, what's interesting is the dust distribution, or how the dust looks throughout the solar system. So as we travel throughout the solar system, the dish looks back at Earth, and so it's kind of in we call it the ram direction, or the direction you're traveling. And that's where we are. We're in the direction of travel because we want to sweep this dust up. And when it hits us, it's not like we collect it and save it or anything. It just obliterates, but we get a signal out of that. But we're mapping this through the whole solar system. We're the only instrument that's been on. All these others have been waiting for Pluto, and that's their prime target. In fact, that's where the production is happening, is out in the Kuiper Belt. And so as we fly through, there's really nothing to take images or to look at these objects. And so that's where we come on, and we measure this dust that we think will actually increase, because like I said, the production's happening out there. So the planets don't have time to collect it out and to decrease the amount. So we're pretty excited to see what happens beyond Pluto.
For other solar systems, if you look at them in certain wavelengths, you see their dust. And so if you understand where our dust is and where our planets are, and you look at other stars and see where their dust is and see lumps, maybe they have planets too.
We were expected to build something at the quality of a professional team, professional adult team would build. NASA would come, and we would have to do reviews just like any other NASA instrument has to go through. It was good training for future, my future career working here. Getting up in front of the NASA folks, and they ask the same type of questions they would ask to professional engineers, and they're asking them to us students. It was up to us to, have the answer.
It's one thing to graduate from school knowing in theory how things work, but to actually having done it makes you much more valuable to your employers. There's less they have to do. And for me, it helped me discover what I wanted to do for my career, which up till then I really didn't know. I knew I wanted to do computers and I wanted to work in space, but I didn't know what that meant for me. But doing this project helped me discover that.
It's kind of going to be a surprise to us what happens after we pass Pluto. We can't slow down at Pluto. We're moving so fast that New Horizons is just going to speed by, and we're going to kind of wave and take some pictures as quickly as we can and take all the data we can. But after that, we will be entering the Kuiper Belt, and we're just going to see how far we can communicate with New Horizons and SDC, and how long we can take data. We don't know. It's a mystery, and we've never been out this far before, so.